Hey guys, good morning, and welcome back again to your Unacademy NEET English channel. I hope all of you doing well, all of you doing great. So my dear students, let me know in the chats if all of you can hear me, if I'm perfectly audible, visible to every one of you. Let me know quickly in the chats if all of you can hear me, if I'm perfectly audible, visible to every one of you. Good morning, guys. Good morning and welcome back. Good morning and welcome back. Good morning and welcome back. Perfect. I believe I'm perfectly audible, visible, yeah? All right. So my dear students, are you all ready for the session? Yeah? Are you all ready for the session? I just want to know that first. Is everyone ready? Yes, even JE students can watch it. Yes, no issues. JE students can also watch the session. I just want to know, is everyone ready to be with me till the end? Well, first of all, I'll tell you one thing, that you need not to worry about anything. All the chapters I'll be starting from the basics only. Okay, I'll be starting everything from the scratch. You need not to worry about anything. Okay, every single thing will be started from the basics, from the scratch. Okay, all right. So today it's going to be complete class 12th physical chemistry marathon. Okay, and my dear students, tomorrow at 8 p.m. it is going to be the extra question practice session. Top 300 most expected questions from your class 12th physical chemistry. That's going to be tomorrow. Okay, that's going to be tomorrow at 8 p.m. exactly. I hope you already have seen the schedule. I hope all of you have already seen the schedule, yeah? All right. Perfect. Is the audio, everything is fine? Someone is saying there's a voice problem. Is there any problem in the audio? I think it's completely fine. No, on my side, I think the audio, video, everything is completely fine. Okay. There is problem from your end, maybe. Okay, you need to refresh once, maybe it'll be fine. I'll keep on giving you the breaks in between as well, don't worry. In between, I'll keep on giving you breaks. After 2.5, 3 hours, I'll keep on giving you small breaks also. Okay, it's not like I'll be taking like 12 hours in a stretch. No, in between, after 3 hours, I'll be giving you some 20 minutes breaks like that, your lunch break, tea break, etc. Okay, perfect. So before starting the session, guys, I want to know one thing. Which part of the country you guys are watching me from right now? See, I'm right now live from Srinagar, Jammu and Kashmir, right? I just want to know which part of the country you guys are watching me from right now. I just want to know that. I just want to know that first, then we'll start. The chats are not stopping. Okay, I can see Karnataka, Andhra Pradesh, Tamil Nadu, Kashmir, Meghalaya, Odisha, AP, Kerala, Manipur, UP, Himachal, Bihar, Kashmir, Sopore, okay, Bangalore, Pondicherry, Srinagar. I think majority is from Majority is from AP and Tamil Nadu. Is that? Oh, Vizag also. Okay. Kota, Telangana. Nice. Bus, I think that's it. That's it. That's what I wanted to see. Got it. Okay, Assam also. Got it. Majority is from AP, Tamil Nadu, Kashmir, Kerala, right? Karnataka. Okay, Maharashtra, Telangana. Perfect. Got it, guys. Got it. Okay, should we start now? All ready? Should we start? I want some fire in the chats. It's a long session. I want some fire in the chats, and I would want you guys to be with me till the end. Okay? Be with me till the end. And whatever things I'll be writing on the screen, take a note of every single thing. And anyways, I'll be providing you the handwritten PDF of this particular session as well in the Telegram channel. I believe you already are the part of the Telegram channel. If not, the name of the Telegram channel is Wassim But Chemistry Official. WASSIM BHAT Chemistry Official is the name of the Telegram channel in which I'll be sharing the handwritten PDF of this particular session as well. Okay? Perfect, guys. So without wasting a lot of your time, let's get going. Let's get started with our today's session. And my dear students, today we are going to complete what? Today we are going to complete the class 12th physical chemistry in detail, in depth, starting from basics, starting from the scratch. Right? So my dear students, the first chapter with which I shall be starting this particular session, that is going to be your chemical kinetics. We shall be starting this particular session with the chapter called as chemical kinetics. Have you studied the chapter before? Just yes or no in the chats. I just want to know. Anyways, I'm going to start from the basics only. Okay? I just want to know whether you have studied the chapter before or not. Quickly. Yes or no in the chats. It's from complete basics. No need to worry. It's from complete basics. Perfect, guys. Got it. Let's move on now. Let's move on and let's have a look. So first of all, my dear students, what all things we have to discuss in chemical kinetics chapter? Let me first of all tell you, chemical kinetics. It deals with the rates of the reactions. Number one, it deals with the rates of the reactions. It deals with the factors that affect the rates of the reactions. And also it deals with the mechanisms which are involved in different chemical reactions. So basically, when it comes to your chemical kinetics chapter, we have to discuss three things basically. We will be talking about the rates of the reactions. We will be talking about the factors which affect the rates of the reactions. And at the same time, we'll be discussing about the mechanisms of different reactions as well. Okay? One by one, we are going to do all these things. Now, the first point which everyone should know from now onwards. What is that first point? My dear students, whenever a chemical reaction proceeds, the concentration of reactants that decreases and the concentration of products that increases. What does that mean? Let's try to understand this first of all. Have a look. First of all, for example, you have got the reaction like this. Let's say you have got the reaction like this, R gives P. Okay. Now, my dear students, here I'm writing time t is equal to 0. Time t is equal to 0 means the reaction has not started yet. And if the reaction has not started, that means the product formation right now would be 0. Okay. So at time t is equal to 0, there will be only and only a reactant present in the container, and let the moles of the reactant be NR. Let's say at time t is equal to 0, the moles of the reactant present in the container is equal to NR. And moles of the product right now is 0 because the reaction has not started yet. Now we know when the reaction will start. When the reaction starts, when reactants started getting converted into products, what's going to happen? I would say number of moles of reactants, they are going to decrease with time, and number of moles of products, they are going to increase with time. Number of moles of reactants, they are going to decrease with time, and number of moles of products are going to increase with time. First of all, I'm defining a term here that's called as concentration, which I'll be representing with square brackets. How do we define concentration? It's a simple thing, my dear students. Concentration is nothing but moles divided by the volume of the vessel, volume of the container in which the reaction takes place. This is something we call as concentration. So first of all, if I write concentration of reactant is simply going to be number of moles of reactant divided by volume of the container in liters. Concentration of product is going to be number of moles of product divided by volume of the container in liters. Simple. Since we know concentration is nothing but moles divided by volume. If I write concentration of reactant, it's going to be moles of reactant divided by the volume of container in which the reaction takes place. Similarly, if I write the concentration of product, it's going to be moles of product divided by volume of the container in which the reaction takes place. Now, my dear students, I told you already, as the reaction starts, number of moles of reactants, they are going to decrease with time. And if number of moles of reactants are decreasing with time, I would say concentration of reactant will decrease with time as well. Similarly, as the reaction proceeds, number of moles of products are going to increase with time. Therefore, concentration of product will be increasing with time as well. Okay. So first of all, the first and the most important thing which you are going to remember from now onwards, whenever a chemical reaction starts, concentration of reactant, it will keep on decreasing with time. Concentration of product, it will keep on increasing with time. Okay. So if you want to represent all of this graphically, you can do that too. For example, I'm making a graph between concentration and time. Okay. At time t is equal to 0, I would say the concentration of reactant will be maximum. And with time, the concentration of reactant is going to decrease. With time, the concentration of reactant is going to decrease, right? Similarly, my dear students, if I want to plot a graph for the product, even for the product, we can plot the graph as well, okay? So if you want to plot a graph for the product, and the graph is again between concentration versus time, so I would say with time, the concentration of product increases, right? So these are the basic graphs which you need to know first of all. So my first point is, when the chemical reaction starts, the concentration of reactant, that keeps on decreasing with time, and the concentration of product, that keeps on increasing with time. As simple as that. Okay? Why is that? Because when the reaction starts, moles of reactant will decrease. And when the reaction starts, I would say moles of product will increase. That is the reason why concentration is decreasing with time for the reactants and why concentration of products increases with time. Now, my dear students, the first topic that we are going to discuss here, what is that? That is your average rate of the reaction. Average rate of the reaction. How do we exactly define the average rate of reaction? Let's talk about this first. Average rate of reaction, which we represent with RAV, it is nothing but, it is defined as change in the concentration of either reactant or product in a given time interval. Change in the concentration of either reactant or product in a given time interval. Now, what does it mean? Before talking about that, let me write one thing here. I'm writing average rate of reaction. Average rate of reaction. I'll be starting with plus minus delta C divided by delta T. Now, why did I write this plus minus? What is this delta C divided by delta T? Let's talk about this once. For example, you have got the reaction like this. A gives B. This is your reaction, for example. Okay. Now, my dear students, let's say at time t is equal to 0, the concentration of this reactant is, for example, C1. Okay. Since the reaction has not started yet, so I would say moles of product right now would be 0, and therefore concentration of product will be 0 as well. Concentration of product will be 0 as well. Now, my dear students, as the reaction starts, the concentration of reactant keeps on decreasing and the concentration of product keeps on increasing. Let's say I'm choosing a time t here. Let's say at time t, the concentration of this A over here is C2 and concentration of this B over here is C3. Okay. This is something I believe every one of you would be knowing already now. At time t is equal to 0, the concentration of reactant is C1, concentration of product is 0. With the time, the concentration of reactant will keep on decreasing and the concentration of product will keep on increasing. So at time t, for example, the concentration of reactant is C2 and the concentration of product is C3. Okay. Now, for example, in this particular time interval, if I want to calculate rate of the reaction, first of all, whenever we calculate rate of the reaction in a particular time interval, we call the rate as the average rate. So basically, I want to calculate average rate of reaction. Now let me tell you, average rate of reaction can be calculated either with respect to reactant or it can be calculated with respect to product. Average rate of reaction can be calculated either with respect to reactant or with respect to product. And how do we calculate it? Try to understand. If I write average rate of reaction with respect to reactant, it will be equal to change in the concentration of the reactant, divided by time interval. This is what? Change in the concentration of either reactant or product in a given time interval. So if I want to calculate average rate of reaction with respect to reactant, it's simply going to be change in the concentration of reactant. And as you see, the concentration of reactant is changing from C1 to C2. So change in the concentration of reactant will be final concentration of reactant minus initial concentration of reactant divided by time interval is 0 to t. This is your time interval. Perfect. But my dear students, if you look carefully, T2 is already less than C1. Because we know as the reaction proceeds, the concentration of reactant decreases. So C2 will be already less than C1. If C2 is already less than C1, I would say this value will come out to be negative. But remember one thing, rate of the reaction can never be negative. So rate of the reaction can never be negative. So what I'll be doing, I'll be just doing one thing. I'll be multiplying this with minus here. Why is that? So that the negative which comes from here and negative makes it positive at the end. Perfect. So one thing, the first thing which you're going to remember, whenever you need to calculate average rate of reaction with respect to reactant, you'll be always starting with minus sign. Then you will write change in the concentration of reactant divided by time interval. As simple as that. Okay. Similarly, average rate of reaction with respect to product, it is going to be equal. Change in the concentration of product. The concentration of product is changing from 0 to C3. So I'll say final concentration of product minus initial concentration of product divided by time interval here is t. Now this value will already come as positive. Perfect. So you need not to multiply with minus, you'll be writing plus here. That is the reason, my dear students, why I wrote here as plus minus delta C divided by delta T. So whenever you need to calculate average rate of reaction with respect to reactant, you'll be starting with minus sign. Whenever you need to calculate average rate of reaction with respect to product, you'll be starting with plus sign. Then you simply write change in the concentration of reactant divided by time interval. Change in the concentration of product divided by time interval. That's all. Okay. Perfect. So that is the reason why I wrote plus minus over here. Now, this plus and minus has got the significance as well. What kind of significance? Let me tell you, minus sign indicates that the concentration of reactant. It decreases with time, and plus sign indicates that the concentration of product. It increases with time. I believe this particular stuff is clear to everyone, right? So what is average rate of reaction if I ask you? Average rate of reaction is nothing but it is defined as the change in the concentration of either reactant or product divided by time interval. Perfect. Whenever I'll be calculating average rate of reaction with respect to reactant, I'll be starting with minus sign. Whenever I'll be calculating average rate of reaction with respect to product, I'll be starting with plus sign. So it's going to be plus minus change in the concentration of either reactant or product divided by time interval. Perfectly done. Now, my dear students, there is one more basic term. What is that? That is instantaneous rate of reaction. Now, what is instantaneous rate of reaction? So let me first of all tell you, instantaneous rate of the reaction. First thing, the difference between average and instantaneous. When we define average rate of reaction, the time interval is bigger. The time interval is bigger. When we talk about the instantaneous rate of reaction, the time interval is very small. So you can say instantaneous rate of the reaction is defined as change in the concentration of either reactant or product in a very short interval of time. In a very short interval of time. Okay, let's try to understand this. Let's try to understand this, guys. See, first of all, I believe in your physics you would be already knowing about average speed and instantaneous speed. So tell me one thing. If I write something like this, delta x divided by delta t, delta x divided by delta t, what do I call this as? Do we call this as average speed in physics, right? Do we call this as average speed? Of course. Now, if I use the limit and put this delta t towards 0, limit delta t approaching towards 0, that means I'm taking the time interval very small. Now, my dear students, I'll be calling it as dx by dt. And this dx by dt is nothing but, this is what you call as instantaneous speed. I hope you know that. I hope you know that. This is what you call as instantaneous speed. Now, my dear students, what exactly I will be doing here? I'll be using the same process. See, first of all, I'm writing delta c divided by delta t. Delta c divided by delta t. This is your average rate of reaction. Now, if I introduce limit and make sure that delta t approaches towards 0, that means I'm talking about the rate of the reaction in a very short interval of time, right? This is something I'll be calling as dc upon dt from now onwards, right? And this dc upon dt I will be again calling as instantaneous rate of the reaction. Perfect. And my dear students, if you look carefully, dc upon dt is going to give me what? It is going to give me the slope of the tangent. It is going to give me the slope of the tangent at a point on concentration versus time curve. It is going to give me the slope of the tangent at a point on concentration versus time curve. Okay, now let's try to understand this a bit more in detail graphically so that you understand its graphical significance as well. See, guys, for example, let me make it over here. For example, here I'm plotting a graph. The graph is between concentration and time. The graph is between concentration and time. Okay, let's say the graph is like this. First of all, with time, as you can see, concentration is increasing. So this is the graph which is valid for product. Okay, this is the graph which is valid for product. Now, for example, I'm choosing a very small interval of time, very short interval of time, very small interval of time, delta t approaching towards 0. This is the very small time interval. Now, in this very small time interval, I want to calculate the rate of the reaction. And whenever you calculate rate of the reaction in a very small time interval, you call that rate as the instantaneous rate. So technically, I want to calculate the instantaneous rate of the reaction. So what I'll be doing, my dear students? What I'll be doing exactly? See, this is the point. At this point, I'll be drawing a tangent. I'll be drawing a tangent at this particular point. After drawing the tangent, I will be calculating the angle which the tangent makes with the positive x-axis in the anti-clockwise direction. This is the angle which I'll be measuring. Let's say this angle is theta. Let's say this angle is theta, right? Now, tan of theta here, what does it give me? It gives me the slope of the tangent. And slope of the tangent gives me what? That gives me the instantaneous rate of reaction. That gives me what? Instantaneous rate of reaction. Perfect. So my dear students, whenever a graph is given and at any point you need to calculate instantaneous rate, what you have to do exactly? You have to draw a tangent, calculate the angle which the tangent makes with the positive x-axis in the anti-clockwise direction, right? You'll be calling that as theta. Now, my dear students, take the value of tan theta. Tan of theta is going to give you the instantaneous rate of reaction. Now, people, what's the point here? Is theta acute or obtuse? Theta is acute. Acute means theta comes in first quadrant. And if theta is in first quadrant, all the trigonometric functions in the first quadrant, they are positive. So tan of theta is already positive here. Perfect. Tan of theta is already positive here. Now, similarly, my dear students, let's say I'm plotting one more graph. The graph is between concentration versus time. The graph is between concentration versus time. Now, you know, with time, concentration of reactant, that decreases. Let's say again, in a very short time interval, I want to calculate the instantaneous rate of the reaction. Perfect. In a very short time interval, I want to calculate rate of reaction, which is what you call as instantaneous rate. So what you will be doing? At this particular point, you'll be drawing a tangent. After drawing the tangent, calculate the angle which the tangent makes with the positive x-axis in the anti-clockwise direction, that is theta. Now take the value of tan theta. Take the value of tan theta. Tan of theta gives me the slope of the tangent, and slope of the tangent is what you call as instantaneous rate of the reaction. You call this as the instantaneous rate of the reaction. Now theta is obtuse here. Theta is obtuse. And if theta is obtuse, tan of obtuse comes out to be negative. Perfect. But I told you, rate can never be negative. So I'll be starting with minus sign here. So that this minus and this minus makes it positive at the end. Perfect. So what is the difference between average rate and instantaneous rate, my dear students? Let me first of all tell you, there's a difference of just time interval. Whenever the time interval is more, that means you're talking about the average rate of reaction. Whenever you need to calculate rate of reaction in a very small time interval, that means you talk about the instantaneous rate of the reaction. Am I clear with this? Yes or no in the chats? Am I clear with this? Yes or no in the chats, people? I hope you got the difference between average rate and instantaneous rate. Now, I'm writing a term here. What is that? It is the rate of the reaction as per stoichiometry. Rate of the reaction as per stoichiometry. What does it mean exactly? Let's try to understand. Rate of the reaction as per stoichiometry. We will try to understand very carefully. For example, I've got the reaction like this. N1A, it gives N2B. Let's say this is a balanced chemical equation, and here N1 and N2, these are the stoichiometric coefficients of reactants and products. These are the stoichiometric coefficients of reactants and products. Now, my dear students, as the reaction proceeds, what happens to reactant? Reactant gets consumed with time. Reactant disappears with time. What happens to the product? Product appears with time. Reactant disappears with time, and the product that appears with time. You all must be knowing that. So here I'm defining a term that's called as rate of disappearance. Rate of disappearance. So first of all, disappearance term is basically for reactant. So I'll be writing rate of disappearance of A. Rate of disappearance of A. How do we denote it mathematically? Since I wrote rate of disappearance, that means I'll be starting with minus sign because I'm talking about disappearance, right? Then I'll be writing change in the concentration of A divided by time interval delta T. This particular term I'll be calling as a rate of disappearance of A. Okay. Similarly, my dear students, if I talk about rate of appearance, appearance, formation, these are the terms which are used for the products, right? So I can say rate of appearance of what? Rate of appearance of B will be equal to what? Since I'm talking about rate of appearance, so I'll be starting with plus sign. Then it's going to be change in the concentration of B divided by time interval delta T. Perfect. So my dear students, whenever from now onwards, you are going to use the term rate of disappearance. That means you're talking about the reactant. Okay. And whenever you want to calculate rate of appearance, that means you're talking about the product. And how do we write rate of disappearance and appearance? In order to write disappearance, you'll be starting with minus sign. Change in the concentration of reactant divided by time interval. Rate of appearance of product will be equal. You'll be starting with plus change in the concentration of B divided by time interval. Right? Now, my dear students, this was rate of disappearance. This was rate of appearance. Now, there is one more thing. What is that? That is basically rate of the reaction. That is basically the rate of the reaction. Rate of the reaction. Rate of the reaction is defined as the rate of disappearance or appearance of reactant or product divided by stoichiometric coefficient of reactant or product. Rate of the reaction is defined as rate of disappearance or appearance of a reactant or product divided by stoichiometric coefficient of reactant or product. Now, how do I write it exactly? See, guys, if I want to calculate a rate of this particular reaction, I can calculate rate of this particular reaction with respect to A as well as with respect to B. Now, if I want to calculate rate of the reaction with respect to A, I'll be right rate of disappearance of A divided by stoichiometric coefficient of A. Now, rate of disappearance of A already we know, that is minus delta A divided by delta T, right? Whole divided by stoichiometric coefficient of reactant is nothing but N1. So I can write it finally as minus 1 upon N1 change in the concentration of A divided by time interval delta T. this particular term here, it gives me what? It gives me the rate of the reaction. It gives me the rate of the reaction. Similarly, if I want to calculate rate of the reaction with respect to B, now B is the product. So I'll write rate of appearance of B divided by stoichiometric coefficient of B. Now, how do we write rate of appearance of B? You know it already, plus delta B divided by delta T, right? So this is rate of appearance of B. This is rate of appearance of B divided by stoichiometric coefficient of B is how much? That is N2. So the value comes out to be plus 1 upon N2, change in the concentration of B divided by time interval delta T. So both the terms, this one as well as this one, both the terms are giving me what exactly? They are giving me the rate of the reaction. So my dear students, if I ask you, what is the difference between, where is the difference when it comes to rate of disappearance and when it comes to rate of reaction? When we write rate of disappearance or rate of appearance, we are not supposed to divide with the stoichiometric coefficient. But when we write rate of the reaction, we are supposed to divide with the stoichiometric coefficient. Is this particular point clear? Again, I'm telling you, my dear students, whenever you are supposed to write rate of disappearance or appearance, you are not supposed to divide with the stoichiometric coefficient. But when you write rate of reaction, you are supposed to divide with the stoichiometric coefficient. For example, if I take one example, with that things will be clear to you. Let's say, my dear students, you have got the reaction like this. N1A plus N2B, it gives N3C plus N4D. Okay. First of all, I'm writing rate of disappearance of A. If I need to write rate of disappearance of A, I'm not supposed to divide with the stoichiometric coefficient. I'll directly start with minus sign, then change in the concentration of A divided by time interval delta T. If I talk about rate of disappearance of B, rate of disappearance of B, again start with minus sign, change in the concentration of B divided by time interval. If I want to write rate of appearance of C, I'll be starting with plus sign, change in the concentration of C divided by time interval delta T. If I talk about rate of appearance of D, it's going to be plus change in the concentration of D divided by time interval delta T. But my dear students, if I want to calculate rate of the reaction, I have to divide with the stoichiometric coefficient. So rate of the reaction with respect to A, I'll be starting, since A is reactant, so I'll be starting with minus. A is reactant, I'm starting with minus 1 divided by stoichiometric coefficient is N1, change in the concentration of A divided by time interval delta T. This particular term gives me the rate of the reaction. Again, I can calculate the rate of reaction with respect to B as well. B is again the reactant. I'll be starting with minus 1 divided by stoichiometric coefficient is N2, change in the concentration of B divided by time interval delta T. I want to calculate rate of reaction with respect to C. Start with plus sign because C is the product, right? 1 divided by N3, change in the concentration of C divided by time interval delta T. Similarly, it's going to be 1 divided by N4, change in the concentration of D divided by time interval delta T. Perfect. This particular equation I'll be calling as differential form. I'll be calling this particular equation as the differential form of rate. The differential form of rate. Okay? The differential form of rate. My dear students, one more important thing. What is that? One more important thing. What is that? Let me tell you, for a gaseous phase reaction, rate is expressed in terms of pressure as well. In terms of pressure as well. What does it mean? What does it mean? Imagine that this A, B, C, D, all of them are in gaseous phase. Imagine that all of them are in gaseous phase, right? Imagine that all of them are in gaseous phase. Now, let me tell you, whenever you have a gaseous phase reaction, for gaseous phase reactions, you can calculate rate either in terms of concentration or in terms of pressure. And how do we write rate of the reaction in terms of pressure? Have a look. I'll write R is equal to, here I'll be starting with minus 1 divided by N1. Minus 1 divided by N1. This is change in the concentration of A. Now I'll write change in the pressure of A divided by time interval delta T. Similarly, minus 1 upon N2. This is change in the concentration of B. So here I'll write change in the pressure of B divided by time interval delta T. It's going to be plus 1 upon N3. This is change in the concentration of C. So I'll write change in the pressure of C divided by time interval delta T. Similarly, plus 1 by N4, change in the pressure of D divided by time interval delta T. So remember, my dear students, whenever you have a gaseous phase reaction and you want to calculate its rate, for a gaseous phase reaction, rate is calculated either with respect to concentration or with respect to pressure. Okay. One more important thing which I would want to tell you here. My dear students, whenever you want to calculate rate of the reaction in moles per liter per second, whenever you want to calculate rate of the reaction in moles per liter per second, you will be using any of these terms and solve it, get the rate of the reaction in moles per liter per second. But if you want to get rate of the reaction in ATM second inverse, if you want to get the rate of the reaction in ATM second inverse, you have to take any of these terms, solve it, and get the rate of the reaction. Am I clear with this? Tell me once in the chats quickly. Everyone. Everyone. Everyone, people. Done? So whenever rate is expressed, whenever rate is to be calculated in moles per liter per second, use this particular one. Whenever rate is to be calculated in ATM second inverse, use this particular equation. So let's try to see how exactly, what kind of questions are asked from this sort of the thing which I told you right now. Let's start with this question. My dear students, if the rate of appearance of O2, is given. So first of all, how do I write rate of appearance of O2? Rate of appearance of O2, how can I write? Since I'm talking about appearance, so I'll be starting with plus sign, right? Since I'm talking about appearance, I'm not supposed to divide with the stoichiometric coefficient. So it's going to be change in the concentration of O2 divided by time interval delta t. This is what I call as the rate of appearance of O2. And as per the question, how much it is? 0.5 moles per liter per second. Correct? What do I need? I need the rate of disappearance of N2O5. Rate of disappearance of N2O5. So people, if I ask you, just give me a second. Okay. So now, rate of disappearance of N2O5 is to be calculated. So mathematically, how do I write rate of disappearance of N2O5? Since I'm talking about disappearance, so start with minus sign. Change in the concentration of N2O5 divided by time interval delta t. So this is what I call as rate of disappearance of N2O5. That needs to be calculated. My dear students, whenever you are supposed to calculate either rate of appearance or rate of disappearance, right? You will first of all have to write the differential form of rate. So in order to solve the question, what I'll be writing? I'll be writing the differential form of rate. So when you write the differential form of rate, I can say rate of the reaction is equal to, with respect to N2O5, I'll start with minus sign, 1 divided by 2. Change in the concentration of N2O5 divided by time interval delta t, right, is equal to rate of the reaction with respect to N2O4 is going to be plus 1 divided by 2. Change in the concentration of N2O4 divided by time interval delta t. Similarly, rate of the reaction with respect to O2, I'll be starting with plus, it's going to be 1 by 1, change in the concentration of O2 divided by time interval delta t. Perfect. This is my differential form of rate. Now people, if you look carefully, what do I need? I need rate of disappearance of N2O5. What am I given with? I'm given with rate of appearance of O2. So from this differential form of rate, I'm going to equate two terms. First term, the one whose data is given. Second term, the one whose data is to be calculated. I'm just going to equate these two. And let me equate them separately here. So I'll write minus 1 by 2 delta of N2O5 divided by delta t is equal. It's going to be plus delta O2 divided by delta t, right? Now, if I just do one thing, if I take this 2 here in the numerator, it becomes minus delta of N2O5 divided by delta t is equal. This is going to be 2 times delta O2 divided by delta t, right? Now this minus delta N2O5 by delta t, what do we call this as? This is called as rate of disappearance of N2O5. So technically, I'm calculating rate of disappearance of N2O5, right? It will be equal to what? 2 times plus delta O2 by delta T. Plus delta O2 by delta T is nothing but 0.5. So the value comes out to be 1 mole per liter per second. Is this what I was supposed to calculate? Simple. Right? Is it clear, people? Everyone in the chats once? Everyone in the chats once? Yeah? Is it clear to everyone? So whenever you are supposed to calculate rate of disappearance or rate of appearance or even rate of reaction, you just have to write what? You just have to write differential form of rate. Nothing more than that. And in the differential form of rate, you just have to equate two terms. That's it. For example, talk about this particular question. You are given with a reaction. 2 times NH3 gives N2 plus 3 times H2. Calculate the rate of the reaction in the interval 5 to 15 seconds. Calculate the rate of the reaction in the interval 5 to 15 seconds. And this is the graph that's given to me. The graph is between concentration and time. Let's say the time is in seconds. Okay. I need to calculate rate of the reaction in the interval 5 to 15 seconds. In this particular time interval, which I represent with delta T, which will be T2 minus T1, which is 10 seconds basically. So in this time interval, I need to calculate rate of the reaction. Correct? In this time interval, I need to calculate rate of the reaction. Now, let's do one thing. My dear students, as you can see, with time, concentration is decreasing. And concentration of what decrease with time? Concentration of reactant decrease with time. Decrease with time. That means this graph is basically for reactant. And which one is the reactant in the reaction? It's NH3. So the graph is basically valid for NH3. Now let's just do one thing. Let's calculate rate of the reaction with respect to NH3. So since NH3 is a reactant, so I'll be starting with minus sign. 1 divided by stoichiometric coefficient 2. Change in the concentration of NH3 divided by time interval delta T. This is going to give me the rate of the reaction. Simple. Now what I'll be doing? I'll be starting with minus 1 divided by 2. Now, change in the concentration of NH3 divided by time interval. Time interval is this, 5 to 15 seconds. Now, at 5 seconds, what was the concentration of reactant? That was 0.6 molar. At 15 seconds, concentration of reactant is 0.2 molar. So, change in the concentration of NH3 will be final concentration of NH3, which is 0.2, minus initial concentration of NH3, which is 0.6, divided by time interval is how much? Time interval is 10 seconds. Perfect. Just solve it, get the answer, that's it. Right? Is it clear to everyone? People are saying the answer is 0.02. Okay, I believe you. It is 0.02 moles per liter per second. This is something you were supposed to calculate. As simple as that. Yeah? Okay, guys? Now, for example, this could be one more type of the question asked. You are given with a reaction and there is some data which is given to me in the question. I need to calculate the relation between K1, K2 and K3. I need to calculate the relation between K1, K2 and K3. My dear students, if you look carefully, first of all, whenever any reaction is given to us, what is the first thing that we do? We write the differential form of rate. So if you write the differential form of rate for this particular reaction, you can write R is equal to, start with N2O5. So I'll be starting with minus 1 divided by 1. Change in the concentration of N2O5. You can write either delta or you can use D. Since in the question, the data of D is given, so I can write D of N2O5 divided by dt is equal to, with respect to NO2, it's going to be plus 1 divided by 2. D of NO2 divided by dt. Similarly, with respect to O2, it's going to be plus 1 divided by, stoichiometric coefficient is 1 by 2, so it's D of O2 divided by dt. Perfect. I just wrote differential form of rate. This is your differential form of rate, my dear student. Now, what exactly I'll be doing? See, 1 divided by 1 by 2 makes it how much? 1 divided by 1 by 2 makes it what? 1 divided by 1 by 2 makes it 2. It makes it 2, right? So it's going to be 2 times basically. It's going to be 2 times here. Perfect. Now, this particular term, its value is given to me in the question. How much? Its value is given to me as K1 multiplied by concentration of N2O5 is equal to 1 by 2. I'm writing as such. This particular term, its value is also given to me in the question. How much? It is K2 multiplied by concentration of N2O5. is equal. This is 2 times d of O2 divided by dt. Its value is also given to me in the question. K3 multiplied by concentration of N2O5. So N2O5, N2O5, N2O5 cancels out. So I would say K1 is equal to K2 divided by 2 is equal to 2 times K3. If I take the LCM of denominators, LCM of denominators will come out to be as 2, right? So multiply throughout with that 2. So I'll say this is going to be 2 times K1 is equal to 2 gets cancelled. So this is going to be K2. This will be 4 times K3. Perfect. So this is the relation between K1, K2 and K3, which I was supposed to calculate. If I'm clear to everyone, let me know once in the chats. Quickly. This can be one more type of the question that can be asked, right? This can be one more type of the question that can be asked from the things which I told you till now. Hey guys, the question is, you're given with the reaction XA gives YB. And this is the data which is given to me in the question. What do I need? I need to calculate the value of X and Y. I need to get the value of X and Y. How do I get the value of X and Y? That is the point now. How do I get the value of... So please repeat the last step. In the last step, I took the LCM of denominators and multiply everyone with that LCM. That's it. Now see guys, this is first of all the reaction. So let's try to write the differential form of rate first of all. When you write differential form of rate, I'll be starting with minus 1 divided by stoichiometric coefficient is X, change in the concentration of A divided by time interval dt is equal to, with respect to B, it's going to be plus 1 divided by Y, so it's going to be d of B divided by dt. So this is my differential form of rate. Now guys, look at the data that's given to me. If you look at this data carefully, this term is given in log, this term is given in log, this term is not given in log. So let's do one thing. If this term is not given in log, let's convert it in log form. How you are going to convert it in log form? That's the point now. So people, I'll write log of minus dA divided by dt is equal to log of d of B divided by dt plus 0.3 is nothing but it is the log of 2. 0.3 is nothing but it is log 2 basically. It is log 2 basically, right? It is log 2 basically. If it is a log 2, what I'll be doing now, I'll write a log of minus d of A divided by dt is equal to log of m plus log of n. Log of m plus log of n is nothing but log of m into n. So it's going to be 2 multiplied by dB upon dt. It is log of m plus log of n, which is log of m into n basically. Okay. Now this is log, this is log. When you multiply both the sides with anti-log, so it gets over. So I'll be left with minus dA by dt is equal to 2 times d of B divided by dt. Now if you take this 2 here in the denominator, it's going to be minus 1 by 2 d of A divided by dt is equal to d of B divided by dt. Now my dear students, do one thing, compare both the equations. When you compare both the equations, this is dA by dt, this is dA by dt, minus 1 by x, minus 1 by 2. So when you compare, the value of x is coming out to be how much? The value of x is coming out to be 2. This is 1 by y, this is 1 by 1. So when you compare, the value of y comes out to be 1. Perfect. This is one more type of the question that can be asked in your examination. Right? So tell me once in the chats. Tell me once in the chats if all this is like very, very, very clear to everyone. Quickly, guys. Tell me once in the chats if all of this is like very clear to everyone. So these are basically some of the types of the questions. These are basically some of the types of the questions that can be asked when it comes to your disappearance, appearance, etc., etc. Okay? All right. Now, my dear students, I'm moving on to one more term, that is your law of mass action. So this law of mass action, which we are going to talk about, let me first of all tell you, it's a complete theoretical concept. It does not have any experimental background. Complete theoretical concept. Okay? And my dear students, this law of mass action was given by two scientists. One is called as Goldberg and second one is P. Vage. These are the two scientists who gave this particular law of mass action. Now, this law of mass action, what does it give me? This law of mass action, it gives us one more way of calculating the rate of reaction. It gives us one more way of calculating what? It gives us one more way of calculating the rate of the reaction. How exactly? Law of mass action says that rate of the reaction is directly proportional to the product of active masses of reactants raised to the powers of their respective stoichiometric coefficients. What does that mean? Try to understand. Well, before understanding this particular definition, before understanding this particular, law of mass action, three things which I want you all to remember from now onwards. What are those three things? Whenever you see any reactant or product in aqueous phase, whenever you see any reactant or product in which phase? In aqueous phase. So that means if in the bracket they write AQ, if in the bracket they write AQ, remember that particular reactant or product which is going to be in aqueous phase, its active mass is nothing but its concentration. That reactant or product which is going to be in aqueous phase, okay, its active mass is nothing but its active mass is its concentration. Whenever you see any reactant or product in gaseous phase, its active mass is its concentration or pressure. Concentration or pressure. Okay. Whenever you see any reactant or product in pure solid or pure liquid form, that means in the bracket, if they write S or L, remember its active mass is constant, which is taken as 1. These are the three things which I want every one of you to remember. Okay. So my dear students, whenever you see any reactant or product in aqueous phase, its active mass is nothing but its concentration. Any reactant or product in gaseous phase, its active mass is either concentration or pressure. When you see any reactant or product in pure solid or pure liquid form, its active mass is taken as constant, that is 1. Okay. Nitin Kumar. Thanks, sir. I am your student and now in MBBS college. That's great. God bless you. Hello, guys. Let's talk about this now. Law of mass action. What this law of mass action says? Law of mass action says that